Good day, students. I welcome you all to Physics for Everybody. Today we'll be solving the Cambridge International AS and A Level February-March Physics 9702 Paper 1 Variant 2 2024 exam. Without delay, let's start. Question number 1. Which row shows a physical quantity and its base unit in the SI system? Quantity, unit. The first one, we have current. The base unit of current is amperes. That is correct. B, false, Newton. Newton is not a base unit. Gram is not the base unit of a mass. It is kilogram. And temperature, the base unit of temperature is Kelvin. Question number 2. A car of mass 850 kilograms is traveling in a horizontal straight line. The diagram shows two horizontal forces acting on the car in opposite directions. One force has a magnitude of 1200 Newton and the other force has magnitude 1600 Newton. What is the magnitude of acceleration of the car? You know, the resultant force acting on the car is equal to its mass multiplied by its acceleration. Now, what is the resultant force acting on the car? It is the difference between the two forces, which is 1600 minus 1200. We'll get 400 Newton. That's the resultant force. So the resultant force here is 400 Newton. So we have 400 equal to the mass of the car. What's the mass of the car? 850 kilogram multiplied by the acceleration of the car. Now, if you want to find the acceleration of the car, you do acceleration equals to 400 divided by 850. If you use your calculator to evaluate 400 divided by 850, you will get 0.47 meters. 0.47 meters per second square, which is the SI unit of acceleration. A, the correct answer to question 2. Question number 3. An object of mass m is suspended by a spring from a fixed point. The spring has a spring constant k and the object is set into vertical oscillations of period t. Which equation for t is homogeneous with respect to base unit? You know, period is equals to 2 pi root L over G for an oscillating pendulum bulb. Also, period equals to 2 pi root M over K for a spring, for a loaded spring. So this is the correct answer, 2 pi root M over K. That is D. That makes D the correct answer to question number 3. We go straight to question number 4. An object of fixed mass is initially at rest at point P. The object then moves away from point P with uniform acceleration. Which statement describes the resultant force acting on the object when it is moving? You know, we were told that the acceleration is uniform. So whenever you have uniform acceleration, then you know you have uniform force. The force must be uniform. That's all. So let's see. Which describing the resultant force, let's see, it increases uniformly with respect to time. No, the force is not increasing uniformly because acceleration is not increasing uniformly. If acceleration were increasing, then the force will be increasing as well. Option B, it is constant but not zero. That's it. It is constant, okay, uniform force. Since it is uniform acceleration, then you have a uniform force, which is constant force. Question number 5. A projectile is launched at an angle of 25 degrees to the horizontal. Okay, so let's just provide a visual representation of that. We have a projectile that is launched at an angle of 25 degrees to the horizontal. Okay, that's good. With a horizontal component of velocity of 13 meters per second. So I'll provide the horizontal component as being equal to 13 meters per second. What is the vertical component of the velocity of the projectile when it is launched? So the vertical component of the velocity is unknown. So if I decide to put that here and call it the vertical component of velocity, from trigonometric ratio, you agree with me that tan theta equals to opposite divided by the adjacent. Okay, since angle theta is 25 degree, we can say tan 25 is equal to, what is the opposite here? That is the unknown, the vertical component of velocity we are looking for, divided by, what's the horizontal component? That's the horizontal velocity, which is 13. So if you want to get the vertical component of velocity, you see the vertical component of velocity is equal to 13 multiplied by tan 25. If you use your calculator to, yes, when you cross multiply, this is what you get. From this expression, you get this. If you do 13 multiplied by tan 25, you will get 6.062. 6.062 meters per second, which is approximately equal to 6.1 meters per second. That makes B the correct answer to question number 5. Question number 6. A ball is released from rest at position X at time 0. At 1 second, it bounces inelastically from a horizontal surface and rebounds, reaching the top of its first bounce at 1.5 seconds. Which horizontal displacement, what is the total displacement of the ball from its original position X at 1.5 seconds? What is happening here is that a ball was released and the ball falls towards the surface of the earth. So when it hits the ground, it then bounces back upwards. So it bounced back upwards, okay, and the ball is eventually at this position. Now they are asking you, what is the displacement? Okay, what is the interval between the starting position and the final position of the ball? How would you solve this question? Just calculate the distance covered, okay? Calculate the distance covered and then you take the difference. That's all you're doing here. Calculate the distance covered and take the difference. What distance am I talking about? The area of this part is the distance traveled while moving downwards, okay? That's why I use color blue to represent the motion of the ball downwards, okay? And what about when it's returning upward? I'm using color orange for that. So this represents while falling, okay, which is represented by color blue. And while moving upward, backward. When moving back upwards, I represented with color green, okay? And this is the displacement, the difference. So how you do that? The area of the blue triangle is half. I'm using the capital letter to represent the base of the big triangle, multiplied by the height of the big triangle, minus that for the small triangle, okay? Half multiplied by small letter b for the base of the small triangle, small letter h for the height of the small triangle. So let's go. The base of the big triangle is 1, okay? And the height of the big triangle is 10, minus half multiplied by the base of the small triangle is 0.5, okay? If you go from 1 to 1.5, you get 0.5. The height of the small triangle is fine. You have minus 5 here, right? The height is actually 5. So what we need is the height, okay? So this minus is already doing the job for you, the difference. So half multiplied by 1 times 10, you have 5, minus half multiplied by 0.5 times 5, you have 1.25. 5 minus 1.25 will give you 3.75 meters. And that makes B the correct answer to question number 6. Question number 7. What is the definition of acceleration? Acceleration is just the rate of change of velocity with respect to time. Okay, with rate of change of velocity, or you say velocity per unit time. Change in velocity per unit time. Excellent. A is the correct answer to question 7. Question number 8. Two balls P and Q of equal masses move along a straight line directed towards each other as shown. Ball P has a velocity of 1.30 meters per second, okay, which is the initial velocity of ball P. To the right, ball Q has a velocity of 0.5 meters per second. That's the initial velocity of ball Q. To the left, P and Q collide with one another. The collision is perfectly elastic and the total momentum is conserved. Which diagram correctly shows the motion of P and Q after collision? Since you were told that the collision is perfectly elastic, what does that tell you? That means after collision, both balls bounce off in opposite direction. Hence, This diagram does not depict such situation because both balls are moving in the same direction. This diagram does not depict the situation because both balls are moving in the same direction. And take note of something. Whenever I hear perfectly elastic collision, it simply means kinetic energy is conserved. Also, momentum is conserved. When you say kinetic energy is conserved, then if you take the difference between the final kinetic energy of the system and the initial kinetic energy of the system, you should get 0. Take note that the balls are of equal masses. Since the balls are of equal masses, then the kinetic energy after collision, the kinetic energy after collision should be giving you the same value. That simply means it's either this ball bounces off with a velocity of 1.3 meters per second after collision, and this other ball bounces off with a velocity of 0.5 meters per second after collision. Or you have this ball bouncing off with a velocity of 0.5 meters per second after collision, and the other one bouncing off with a velocity of 1.30 meters per second after collision, but they must bounce off in opposite direction. Yes, so if you do that, you will get the same answer because we are told that they have equal masses. You don't have the exact mass, so that one will give you the correct answer to that. So if you look at the option we have here, we have 1.9 meter per second, 0.9 meter per second. If you solve this, fine, they are bouncing off in opposite direction, okay, which satisfy the condition of elastic collision. But since it's perfectly elastic, kinetic energy must be conserved. So if you use the formula m1u1 plus m2u2 equal to m1v1 plus m2v2 for the conservation of momentum, and you use the formula have mv squared, that's the formula for kinetic energy, have m1 u1 squared plus half m2 u2 squared. You know, that's the initial kinetic energy. If you are subtracting the initial kinetic energy from its final kinetic energy, if you are subtracting the initial kinetic energy from the final kinetic energy, you should be getting 0. And if you substitute those values for V, you won't get 0. These are the only values that will work, okay? You know, the first one, traveling with an initial velocity of 1.3. P has an initial velocity of 1.3 meters per second. That means after collision, P must have 1.3, okay? Or P having 0.5 after collision, while Q has 1.3 after collision. And that's what we have here. P is having 0.5 after collision, okay? You can see P is now taking this value here. P is now taking the value of velocity of this one after collision, while Q takes velocity of this one after collision. And that is what works, okay? If you substitute those values, you get the change in kinetic energy to be 0. Okay, so that's D is the only one that will work for that. We go straight to question number 9. A basketball player hits a ball vertically downwards with a speed of 2.4 meters per second from a height of 0.9 meters. Air resistance is negligible. What is the speed of the ball as it hits the ground? You know, a basketball player hits a ball vertically downwards. So you are giving the ball an initial velocity downward. So you have an initial velocity of 2.4 meters per second. And the ball is traveling through a distance of 0.9 meters. Now you have to calculate the speed of the ball as it hits the ground. So you are looking for the final velocity. Now we bring in the equation of rectilinear motion, taking note that G is equal to 9.81 meters per second square. Which equation of rectilinear motion would you use? Okay, or equation of motion under gravity would you use to solve this question? So after listing out these variables, I will list out my equations of rectilinear motion and I will ask myself, which of these equations of rectilinear motion has this variable? Has u, v, h, and g. It is the second one, v squared equals to u squared plus 2as. So the modified one, motion under gravity, would be v squared equals to u squared plus 2 GH, okay, where G is the acceleration due to gravity and H is the vertical distance, which is the height. So V squared, which you do not know, equals to the U squared, which is 2.4 squared, plus 2 multiplied by G is 9.81, and the height is 0.9. This will give us v squared equal to, use your calculator to evaluate this, you will get so v squared equals to 23.42. To get the value of v, you take square root of both sides, and v will give you 4.8 meters per second. That makes B the correct answer to question number 9. Question number 10. A ball falls through a liquid at a constant speed. It is acted upon by three forces: an upthrust, a drag force, and its weight. The liquid has uniform density. Which statement is correct? Option A. The drag force increases with increasing depth. The drag increases with increasing velocity. But since the liquid is falling and drag continues to act on the body, then drag will be decreasing. Why? Because the velocity of the body is decreasing. B. Drag force is equal to the sum of upthrust and weight. Drag is not equal to the sum of upthrust and weight, because weight is constant. Fine, weight is constant. Then as the body falls, the drag force continues to reduce because the velocity of the body, a ball falls to a liquid at constant speed. In fact, speed is constant, then drag must be constant. Okay, drag must be constant if speed is constant, and drag is not equal to the sum of the upthrust and weight, because the weight acts downwards. Okay, weight acts downwards while drag acts upwards, and upthrust acts upward, drag acts upwards. So the weight should actually be equal to the sum of upthrust and drag. Option C. The upthrust is constant with increasing depth. The upthrust is constant with increasing depth. Of course, upthrust must be constant because it is now moving at a constant speed. Upthrust is constant. Okay, yeah, that's fine. Upthrust does not depend on depth. Okay, upthrust is constant. Option D. The weight is greater than the sum of drag force and upthrust. The sum of drag force and upthrust, if you add this together and weight is greater than this sum, then it simply means the velocity of the object is increasing. Okay, but since we have constant speed, then the weight must be equal to the sum of these two. Weight must be equal to the sum of those two. So C is the only correct answer. That makes it the correct answer to question number 10. We go to question number 11. Some small solid cubes each have mass 1 kilogram and sides of length 5 centimeters. These small cubes are stacked together to form a huge solid cube with sides of length 2 meters. What is the weight of the large cube? And you know, weight is equal to mass times gravity. Weight is equal to mass times gravity. How do you get the mass? Mass equals to density multiplied by volume. Now how are we going to get the volume? You know, according to the question, we were given that each mass of 1 kilogram of the cubes has a length of 5 centimeters. Then volume is equals to L cube, which is the formula for the volume of a cube. Don't forget that the question has referred to them as cubes. So what is the length? The length is 0.05 meters. You know, if you convert 5 centimeters to meter, you get 0.05 meters. Now, volume is length raised to power 3. If you do 0.05 raised to power 3, you get 1.25 multiplied by 10 raised to power, I think that should be 10 raised to power minus 4. Yes, that should be 1.25 times 10 raised to power minus 4 meter cube. Now, how do we get the mass? We use this formula. Mass equals to density times volume. Okay, we have the density already. We already have the density of the cube. What's the density of the cube? We were given in the question. We were given the density in the question. Okay, how do you get the density? Density equals to mass. Okay, yeah. So the first thing we do is to calculate the mass of the cube. How do you get the mass of the cube? Okay, so I've solved the question here, but let me come back here to put it here. Now I have the density as density as mass per unit volume. Density is mass per unit volume. Since every 1 kilogram mass has a volume of 1.25 times 10 to the power minus 4, then I can get the density as 8,000 kilogram per meter cube. Now, if this is a density, how do I not get the mass? mass equal to density times volume. Now, those small cubes were stacked together to form a big cube of size 2.0 centimeters, okay, to form large solid cube of this side. So if this is the side and it is a cube, how do I get the volume of this cube? The bigger one now has a volume of length raised to power 3. The length is 2.0 meters, so I will do 2 raised to power 3, which will give me 8 meter cube. So if that is the volume, then putting this into the formula for mass, mass is density, which I have as 8,000, multiplied by the volume, and I have the volume as 8. 8,000 multiplied by 8, I'll have 64,000 kilogram. Now I can get the weight. Weight is mass multiplied by g, mg. I can use this formula to get the weight, okay? Mg. Now the weight is equal to mg. The mass is 64,000. Multiplied by g is 9.81. Use your calculator to evaluate 64,000 multiplied by 9.81. You should get 6.3 times 10 to the power 5 Newton. 6.3 times 10 to the power 5 Newton. And where do I have that? 6.3 times 10 to the power 5 Newton. That will be 0.63 meganewton. That is C. The correct answer to question 11 is C. Now to question number 12. A borehole of depth 2,000 meters contains both oil and water as shown. The depth is 2,000 meters. The pressure due to the liquids at the bottom of the borehole is 17.5 megapascal. So the pressure down here is 17.5 megapascal. The density of the oil is 830 kilogram per meter cube. The density of water is 1,000 kilogram per meter cube. What is the depth X of the oil? What would you do here? Now, looking at this question, since you were given the density due to both liquids at the bottom of the borehole to be 17.5 megapascal, then the smartest thing for us to do is calculate the pressure due to the oil, then calculate the pressure due to the water alone and add them together. How do you get pressure due to the oil? Pressure due to the oil is density of oil times acceleration due to gravity multiplied by height of the oil. What is the height of the oil? X is not given to us, right? Good. So we multiply the density of the oil, which is 981. No, density of the oil is 830. 830. We already have density of the oil is 830. Gravity is 9.81. Multiplied by the height of the oil is X. Multiply these three, you will get okay, let me leave it like this. What about for the water? Pressure due to the water will be equal to density of the water multiplied by gravity multiplied by height of the water. Density of water is 1,000. Acceleration due to gravity is 9.81. Height of the water, height due to the water, is it given to us? Height of the water, okay, since height of the water is not given to us, then we have that as, let me see. Okay, let me just represent it with the alphabet Y, okay? Yeah, since it's not given to us, multiplied by Y. So this will give us another equation. Now we have these two expressions. So we now express density, pressure due to oil plus pressure due to the water must give us this value, which is 17.5 megapascal. Yeah, so that's the smartest thing for us to do. Now let's solve this question. Take note that the total height for both of them is 2,000. Now let's solve it. Okay, one more thing. If you look at this diagram, okay, you can see that y equals to 2,000 minus x, right? Y equals to 2,000 minus x. So in order to make our work easier, instead of putting y here, I will put 2,000 minus x here. 2000 minus x. So this will make my work easier. Now let's substitute, okay? Density, pressure due to the water alone, which is 830 multiplied by 9.81. So I'll multiply 830 by 9.81. So this will give us, multiplying these two together will give us 8142, 8142.3x, okay, which is equal to the pressure, contribution of pressure due to the oil alone, okay. Then contribution of pressure due to the water, we have this, okay, 1000 multiplied by 9.81, that should be 9810, open bracket, 2000 minus x. All of this should give us 17.5 megapascal. So what do I have here? That will be 8142.3x plus, now I'm going to expand this. When I expand this, what will I get? If I open the brackets, I will have 1.96 times 10 raised to power 7. 1.962 times 10 raised to power 7 minus 9810x. This should give me 17.5 times 10 raised to power 6. Okay, since it's megapascal, mega is times 10 raised to power 6. Now, what's the next thing here? I want to collect like terms. Okay, I'll bring this x here. Okay, I'll get a negative answer. Okay, well, it's fine. I'll bring this here. Yes. So I have 8142.3x minus 9810x is equals to 17.5 times 10 to the power 6 minus 19.62 times 10 to the power 6. I think it's easier that way. This is the same thing as writing 19.62 times 10 to the power 6. Now, let me take the difference. 17.5 times 10 to the power 6 minus 19.62. That should give me a negative answer. Yes, I'll get a negative answer there. So this is what I'll get. I'll get negative answer for both sides. So my x is now equal to minus 2.12 times 10 to the power 6. I will divide this by minus 1667.7. At the end, I will have my x as 1271.2 meters. I will express my answer to the nearest 3 significant figure, okay? So 3 significant figures, since the highest significant figure I have here is 3. And that will give me 1270 meters. That makes D the correct answer to question number 12. We go to question number 13. A rod is pivoted at one end. Initially, the angle theta of the rod to the horizontal is 0 degrees. So a rod is pivoted at one end and the angle theta was 0 degrees. Let this be the pivot. Okay, let's go. The weight of the rod causes a moment M about the pivot. The weight of the rod causes a moment M about the pivot. The rod is then rotated in the vertical plane so that angle theta of the rod increases from 0 degrees to 180 degrees. A rod is pivoted at one end. Initially, angle theta of the rod to the horizontal is 0 degree. Okay, so it's rotated at 180 degrees. So the rod goes this way, okay, and takes this new orientation. Okay, yeah, so let me leave that for now. Which graph shows the variation of M with theta? Okay, so when theta was 0 degree, what was the moment? You see the distance. The distance is large. Let me use color red to represent the distance. You see how large the distance, the perpendicular distance between the point where the force is applied and the pivot is. Now, when the rod is acting in the vertical position, you know it rotates 90 degrees. Now, when the rod is at this point, okay, the weight acts here along the center of gravity. Hence, the distance between where the weight acts and the pivot is 0. At this point, the moment becomes 0. Okay, in this initial position, the moment here is maximum. Okay, when it's here, the moment becomes 0. And when the rod eventually gets to the final position, when the rod is acting this way, let me use this color for that. When the rod eventually becomes like this way, and this is where the weight acts. Okay, you see there is another distance. Okay, the distance appears again, and moment becomes maximum. That means the moment goes from maximum to 0 and then back to the maximum value. And which option gives us that? Let's see what we have here. And okay, take note of one other thing. Fine, the moment goes from maximum to 0 back to maximum. But take note that the moment here is a clockwise moment. While when the rod becomes like this, the moment here is an anti-clockwise moment. Okay, so direction must also be put into consideration. Okay, if we are not considering direction, you would have chosen B. Okay, because the moment goes from maximum to 0 and back to maximum. But because we need to consider the direction, that's why we have to pick D. The moment goes from maximum to 0 and back to the maximum in the opposite direction. Okay, yeah, that's why we are picking M along the negative axis, okay, as the final value. That's why we are picking D as the correct answer. I believe this is perfectly understood. If it's not understood, please watch this part of the video again. We go straight to question number 14. Question 14. A hinge cap door is held closed in the horizontal position by a cable. This is the cable. Three forces act on the trapdoor. The weight W of the door, the tension T in the cable, and the force H on the hinge. Those are the three forces that hold the door in equilibrium. So those are the three forces: the weight, then the force on the hinge, and then the tension in the cable. Now let's see. Which list gives the three forces in increasing order of magnitude? Now, how do you have the increasing order of magnitude? Take note that these two forces in color blue act in the downward direction, and the only force that acts in the upward direction is this one that I'm putting in color red. This tension T is the only one acting in an upward direction, while the other two act in a downward direction. So which one do you think should be the highest, considering this condition? Which one do you think should be the highest? And you know the resultant forces on the object must be equal to 0. Automatically, you know T must be the highest. Okay? Yes, because the sum of the vertical components of H and W, if you add the vertical components of H, add it to W, it should give you the vertical component of T. So automatically, T must be the highest. Okay, increasing order, T must be at the rightmost end. So in fact, you can already see this is the only one where T is at the rightmost end. This should be the correct answer. Then also, we now have to consider other factors such as resolving vectors. Yes, if you have to resolve the vectors, then you know very well that H must be high, so that by the time you resolve the vertical components, it gives you a reasonable value that sets the trapdoor in equilibrium. So H must be very, very high because it is inclined at an angle. Okay? Yes, H must be high. Look at tension. Tension is also inclined at the angle and is the only force that acts in the upward direction. So it must be very, very high in comparison with the others. So that makes it the only correct answer to question number 14. So this is an application of your knowledge of resolution of vectors, okay, and the condition necessary for a body to be in equilibrium. What is the definition of force? Question 15. A, the product of mass and acceleration. Yes, that makes sense, but that is not the definition of force, because force is mv minus u over t. Fine, v minus u over t will give you acceleration, but this is change in momentum, while the denominator is time. So force is the rate of change of momentum with respect to time. Rate of change of momentum, or you say time rate of change of momentum. That makes it the only correct answer to question number 15. Question number 16. A boat moves at a constant velocity v through still water. A drag force F acts on the boat. What is the power used by the boat to move through the water? You know, the formula for power Power is energy over time, right? Yeah, and the energy can be kinetic energy or gravitational potential energy. Just divide it by time, you get the power consumed, okay? Power used. Now look at this. And also, we can also express power as work done divided by time, where work is force times distance, okay? Yes, divided by time. Take note that the distance is the distance moved in the direction of the force, okay, which can be expressed as displacement. Now, power is force multiplied by displacement over time, where displacement over time is what? Velocity. Power equals to force times velocity. That's it. Option B is the correct answer to question number 16. Question number 17. The diagram shows four forces acting on a circular disk. Each force has a magnitude F. Two of the forces act vertically and two other forces act horizontally. Fine. All forces act in the same plane as the disk. No other forces act on the disk. The disk has diameter of d. Which statement is correct? Now, looking at what we have here, you can see that option A, let's see, option A, the disk is in equilibrium because the resultant force is 0. Fine, the resultant force is 0, but all these forces will create a resultant clockwise moment. So you cannot say the disk is in equilibrium. Yes. The disk is not in equilibrium because the resultant force is 4F. No. Of course, the resultant force will be 0, considering the direction. Opposite forces, fine. Resultant force will be 0. But what about the moment? Will the resultant moment be 0? Option C, the disk is in equilibrium because the resultant torque is 0. No, there's a resultant torque. Yes, there's a resultant force, torque. This is the center, and each of these is at a distance d over 2. Don't forget that the diameter is d. So each of these forces is at distance of d over 2 from the center, and they are creating their own moment. So there'll be a resultant clockwise moment, okay? Yes, the disk is not in equilibrium because the resultant torque is 2Fd. Yes, if you do force multiplied by the displacement, which is d over 2, do that 4 times, okay? Because there are four forces, each of them at d over 2. You will get 2Fd. Yeah, why? Because 2 here is 1, 2 here is 2, which is 2Fd. Question number 18. A ball is projected into the air from horizontal ground and follows the path shown in the diagram. At points Q, R, S, and T, the ball has kinetic energy EQ, ER, ES, and ET, respectively. The heights above the ground of these 4 points are shown. Air resistance is negligible. Which difference in kinetic energies is the smallest? Okay, so if it's projected into the air from ground level, so if you are projecting a ball this way, you know very well that at this point, kinetic energy at this point is higher than kinetic energy at this point. Why? Because the horizontal component of the velocity is constant. Horizontal component of velocity is constant. So at this point, the center point, the ball has only horizontal component of velocity. But at this point, it has both the horizontal component and a vertical component. So at this point, it has higher velocity, smallest velocity, okay? So that's what happens at this point. So you can see that at this point, it has high kinetic energy. At Q and T, it has high kinetic energy. In fact, the kinetic energy is highest at T because T is closer to the ground level. T is the closest to the ground level. So where do we have the highest? Just consider where we have the highest difference in height. Yes, that's the most reasonable point. Okay. So let's see EQ minus ES, EQ being here, then ES, energy at S. Is it this one? Let's look at the second option. EQ minus ES. Okay. Which difference in kinetic energy is smaller? Oh, smallest. EQ and ES are close to being equal. So this shows the smallest difference. Don't forget that we are taking the difference, okay? So these two are close to being equal. So this will really give you the smallest. It should be A. Because if you look at B, ES minus ER, energy at S, kinetic energy at R. Kinetic energy at S is bigger than kinetic energy at R. So if you want to take the difference, you get higher value. Yes. When 2 points are close to being at the same horizontal level from ground level, they have the same kinetic energy, okay? And they are considered to have almost the same speed, almost the same kinetic energy. If they are at the same horizontal level from ground, then they have the same velocity and they have the same kinetic energy, okay? Yes. While a point like this has the smallest kinetic energy and the smallest speed, and these 2 points down here have higher speed and highest kinetic energy. That's it about that's one thing about projectile. Question number 19. A battery of small tablet computer is initially uncharged. It is connected to a constant 10-watt power supply for 2 hours. We have the power, we have the time to charge the battery. The efficiency of the charging process efficiency is 80%. What is the total energy stored in the battery? What's the formula for electrical energy? Bit electrical, in fact, the general formula for energy is power multiplied by time. Okay, now we have to factor in the efficiency of the charger. Okay, the efficiency of the charging process is 80%. Now bringing that into the situation, what will you do? So we multiply by the efficiency. Okay, power times time multiplied by efficiency. Power is 10 watts, time is 2 hours. Don't forget that we have to express our time in seconds by multiplying it by 60 times 60 or by 3600. That's how you convert from hour to second. Now we multiply all of these by the efficiency, which is 80%. If you use your calculator to multiply all of this, you should get hold on, let me use my calculator to do this. So I got 5.76 times 10 to the power 4 joules, and I'm writing this in standard form. That will be 5.8 times 10 to the power 4 joules. C. That makes C the correct answer to question number 19. Question number 20. An initially stationary firework explodes and splits into 2 fragments that move horizontally in opposite direction. The total kinetic energy transferred to the fragment by the explosion is E. One fragment has mass m and the other one has mass 2m. What is the speed of the fragment of mass m immediately after the explosion? Now look at this, since they split into 2 and move in opposite direction, then an M1V1 must be equal to M2V2. One of the masses have the mass M1 equals to M and M2 equals to 2M. Okay, so what can we get from this? Now let us refer to these objects having mass M1 of mass M, M1 having mass M. Let us assume the velocity V1 equals to V. How do you get the value of V2? Now, since M1 V1 equals to M2 V2, that simply means let's put the values of M1 there. We said M1 is equal to M. So we have M multiplied by V1 is equal to V. MV equal to M2, which we do not know. No, M2 is equal to 2M. Yeah, since one of them has double the mass of the other two. So it must be equal to 2M multiplied by, what is V2? We do not know V2. Okay, since we are looking for V2, right? Divide both sides by 2M. Divide both sides by 2M. So 2M will cancel out here. 2M will cancel out here. We have V2 equal to M will cancel out M over 2. V2 is equal to half V over 2 half V. Okay, that simply means that if V1 is V, then V2 will be having half the velocity. Now, the total energy transfer, total kinetic energy released during the collision is during the explosion is E. Let me put this in a smaller space. V2 equal to half V. Now, take note that as for kinetic energy, half m1 v1 squared, half m1 v1 squared plus half m2 v2 squared must give you E, which is the total kinetic energy. Let's substitute into this. Half m1 is equal to m, okay? So half m1 is m, multiplied by v1. v1 is equal to v, okay? V squared plus half m2 is equal to 2m. So half multiplied by 2m, then multiplied by v2. v2 is half v squared. Sum this together, it should give you E, since E is the total energy. Half multiplied by m multiplied by v squared, fine. That will be mv squared over 2, okay, plus half multiplied by 2m, that will be m v squared divided by half multiplied by 2m, that will be 1. So half will cancel the 2. So you just have m multiplied by v squared over 2 squared. Since this is half squared, then denominator will be 4. Add this together, you should get E. Half plus 1 over 4, that should be 3 over 4. That simply means 3 over 4 mv squared should be equal to E. What are we looking for? We are looking for V. Okay, so let me finish this on this left-hand side. Since 3 over 4 mv squared is equal to E, let's divide both sides by 3 over 4m. That simply means V squared is equal to E. V squared equal to E divided by 3 over 4m. Automatically, we say V squared equals to 4 over 3E over m. Yeah, if you evaluate this, you get 4 over 3E over m. And that simply means V is equal to the square root of 4E divided by 3m. That makes D the correct answer to question number 20. Here's to question number 21. A spring is fixed at one end and extended by applying force F to the other end. The spring has extension X and elastic potential energy EP. The spring constant is K. The spring obeys Hooke's law. Which relationship is correct for the spring? EP is proportional to F. The elastic potential energy is proportional to F. Elastic potential energy. Okay, yeah. The spring has elastic potential energy EP. So is elastic potential energy proportional to F? Fine. That makes sense, okay? But take note that the elastic potential energy is proportional to the force that you apply minus frictional force. Yes, okay? So that will give you the resultant force that caused an extension. So elastic potential energy is proportional to the resultant force that caused that extension, which is force applied minus frictional force. Okay, so that means A is not good. Let's see, elastic potential energy stored in the spring is proportional to X. Well, that is not good enough because elastic potential energy is half kx squared. So it's not proportional to X, it's proportional to X squared. So this is also not good. The third one, elastic potential energy is proportional to spring constant. Okay, that's fine. Elastic potential energy is proportional to spring constant. Okay, but in this situation, we are not using K because we have the force, we have the extension. Okay, so if you want to use what we have, which is the force and the extension, we say elastic potential energy is proportional to fine, elastic potential energy, energy work done rather, or energy dissipated in stretching the spring is proportional to K. Yes, the energy dissipated in stretching the spring is proportional to K. Okay, yeah, F equals to energy is equals to have the difference between force applied minus friction. Okay, X. Fine, this is gonna work. Okay, but this is the one that perfectly addresses the situation. Why? Because energy is equals to half kx squared. So since these are constant, then you can say energy is proportional to x squared, where x is the extension. Okay, that's why we are picking D. Okay, so energy is proportional to K is not the perfect answer. Okay, energy is proportional to K is not the perfect answer. So let's see the next one. A force extension graph is produced for a metal wire. What must describe the limits of proportionality of the wire? Whenever you hear the term limits of proportionality, what comes to your mind? That is the point beyond which the extension is not proportional to to the force applied. Okay. Okay, so extension is not proportional to force applied. Okay, yeah, and that is in line with Hooke's law. Remember Hooke's law? Yes. So a point at which wire breaks, no, that's break limit, not this. B, the point beyond which Hooke's law is not obeyed. That's it. Okay. So according to Hooke's law, extension is proportional to force, and once extension is not proportional to force, then Hooke's law is no longer obeyed. That makes B the correct answer to question 22. Question 23. A spring has a spring constant of 6 Newton per centimeter. It is joined to another spring whose spring constant is 4 Newton per centimeter. A load of 8 Newton is suspended and from this composite spring. What is the extension of the composite spring? And you know very well, since E equals to F over K, we have the force as 4 Newton. Do you have the spring constant of the composite? No. How do you get the spring constant of the composite? Whenever you have a composite combination like this, then you have 1 over K equals to 1 over K1 plus 1 over K2. But the simplified expression you always use, K equals to K1 K2 over K1 plus K2. This formula will give you the spring constant. So I want to get my spring constant by using K1, K2. K1 is 6 Newton per centimeters. K2 is 4 Newton per centimeters. So I'm doing K1, which is 6 multiplied by K2 is 4 divided by K1 plus K2, 6 plus 4. 6 times 4 is 24, 6 plus 4 is 10. That will give me 2.4 Newton per centimeter. So now I have my spring constant. I can now get my extension by doing force divided by spring constant. The force is 6. No, the force is not 6. The force is 80 Newton. So I have 80 divided by spring constant is 2.4 Newton per centimeter. 80 divided by 2.4. If I do that with my calculator, I will get 33.33 centimeters, which is option D. Question number 24. The range of frequencies of sound waves emitted by blue whales is 10 Hz to 40 Hz. The speed of sound waves in seawater is approximately 1.5 kilometers per second. Now the question, what is the approximate range of wavelength of sound waves emitted by blue waves? No, now you know that the wave equation V equals to F lambda. That simply means the wavelength equals to V over F. Now let me get the wavelength for the upper bound and the lower bound of frequency. This is the lower bound of frequency. This is the upper bound of frequency that is emitted by blue whales. So wavelength lambda 2 equals to V over F upper bound. So the speed is 1.5 kilometers per second divided by frequency. Of course, 1.5 kilometers per second simply means 1,500 meters per second. So I'm using the speed of 1,500 meters per second Divide by frequency, the upper bound of frequency is 40 Hertz. 1500 divided by 40, I should get 378.5. 1500 divided by 40. So this will give me, so I got 37.5 as the lower bound of the wavelength. And let me get the upper bound of the wavelength. I will divide the velocity by the lower bound of the frequency, which is 1500 meters per second. I'll divide it by 10 hertz. 1500 divided by 10, I'll get 15 meters. So the range of frequency goes from 15 meters to 37.5 meters. Which option do we have there? 15 meters to 37.5 meters. Oh, sorry. 1500 divided by 10 is 150. Pardon me. This is 150 meters. Yes. So that is so the frequency, range of frequency goes from, range of wavelengths rather, is go from 37.5 meters up to 150 meters. That is yes, 37.5 is approximately 38. That makes B the correct answer to question number 24. We go straight to question number 25. A sound wave is detected by a microphone and displayed on the screen of a cathode ray oscilloscope. The frequency of the wave is 2.5 kHz. What is the setting on the time base of the cathode ray oscilloscope? Since we have frequency, we have to start by getting the period. Okay, frequency is 25 kHz. What is period? Period equals to 1 over frequency. Since the frequency is 2.5 kilohertz, that means frequency is 2500 hertz, then it simply means the period is 1 over 2500. 1 over 2500, that will be 1 divided by 2.5 will be 0.4. So that will be 0.4, but we have 0, 0, 0, 0, 0, 0, 4. That's the period, okay, which is approximately equal to 0.4 milliseconds. That's the period. So by looking at the time base you have here, that simply means the period is 0.4 milliseconds. So from here to here is 0.4. Okay, that's one period. And the second period, another period will be 0.4. They are asking for the time base. That means so if 1, 2, 3, 4, if 4 boxes represent 0.4 milliseconds, then it simply means if 4 boxes represent 0.4 milliseconds, and don't forget that 1 box is 1 centimeter. So it simply means if 4 centimeters represent 0.4 milliseconds, then it simply means 1 centimeter will be 0.1 millisecond. And that should be the time base, okay? What is the setting on the time base of the cathode ray oscilloscope? So 1 millisecond per centimeter. No, it is 0.1 millisecond represents 1 centimeter. So this should be 0.1 millisecond per centimeter, or you say 0.1 millisecond, then centimeter is to the power minus 1. That's it. That should be A. The correct answer to question number 25 should be A. Is A. Yeah, that's it. So we go to question number 26. A source of sound waves with constant frequency moves towards a stationary observer. The observer compares the sound waves arriving at the observer's position with the waves emitted by the source of sound. What is detected by the observer? A. A decreased frequency of the sound. Okay, since the observer is approaching, a source of sound wave, since the source is approaching the observer, what happens? Then the wavelengths that were emitted by the source, since the distance continues to increase, then what the observer would observe would be as if the waves are coming closer, very close to each other. The waveform that were spaced from each other would appear closer. Why? Because they are moving close to each other. Distance continues to increase. So that's what happens to the waves, okay? The waveform becomes close together. What I'm simply saying is that this is the wavelength of the emitted sound. What will be heard? This will be the wavelength of what will be heard. So there will be a decrease in wavelength. That makes option C the correct answer to question 26. 27. Which type of waves cannot be polarized? Longitudinal waves cannot be polarized. All longitudinal waves. Sound wave is a longitudinal wave, hence sound wave cannot be polarized. Number 28. A beam of light with power P has an area of cross-section A. The amplitude of light waves in the beam is X. The beam of light is then changed to one with the frequency but sorry to one with the same frequency but with an increased amplitude of 4x. So we have same frequency, increased amplitude, and the area of cross section is now reduced to 1/3 of what it was before. What is the power of the new beam? Now take note of something about beams of light, that power divided by cross-sectional area multiplied by the amplitude square must give you constant. It must be constant for all sources of light, for beams of light. Now, you are replacing the first one with the second source of light. That means the power of the first one divided by its cross-sectional area multiplied by its amplitude square must be equal to the power of the second one. So let's represent the power of the second one with P2 must equal to the power of the second one multiplied by the cross-sectional area of the second one multiplied by the amplitude of the second light source squared. So since it is changed to another beams of light multiplied by the second beam squared. Now let us substitute the values. You know, we are looking for P2, right? So from this we can see that power of the second light source is equal to what? Power of the first one multiplied by cross-sectional area of the second one multiplied by its amplitude squared divided by cross-sectional area of the first one multiplied by its amplitude squared. Now you were told that the amplitude of the second one is 4 times the amplitude of the first one, while the cross-sectional area of the second one is 1/3 of the area of the first one. Now we put those values into this expression. So we see the power of the second one will be power of the first one multiplied by cross-sectional area of the second one is 1/3 of the area of the first one. So I have A over 3 multiplied by amplitude squared, x squared, okay, which is the amplitude of the first one, x. No, A2, this should be x2, okay, when you cross multiply, x2 should multiply by P. A2, x2 should go up here. So this will be x2 squared, yeah. And don't forget that x2 equals to 4x. So now that I'm having x2 squared, x2 is 4x, right? Now I'm to square it. Yes, because it is being squared here. So I'm to square it. Then I will divide by what? I will divide this by ax squared. Ax squared. So looking at this, what do I have here? This will give me P2 equals to P multiplied by A over 3 multiplied by 16x squared. Divide all of this by ax squared. Now, what can I cancel out here? I have a here, I have x squared here. So I'll just have P multiplied by 16 over 3. 16 divided by 3 is 5.333. So P2 equals to 5.3333333 P2. Write to two significant figure because all my values, do you have any number of significant value? No, I don't have any. Okay, then I can just write it to two significant figure, which is 5.3p. Okay, yes, considering the options given to me. So that makes B the correct answer to question number 27. We go straight to question number 28. two loudspeakers are connected to the same signal generator. A loudspeaker, another loudspeaker, a signal generator. To a signal generator. This is a microphone. The signal generator produces a single frequency. The loudspeakers face each other so that stationary sound waves set up in the region between stationary sound waves is set up in the region between the loudspeakers. A microphone connected to a cathode ray oscilloscope and positioned between the two loudspeakers. So this is the microphone. The microphone is moved along a line joining the two loudspeakers. The signal on the cathode ray oscilloscope shows 5 maximum amplitudes as the microphone moves. The microphone moves a distance of 2 meters from the position that gives the first maximum to the position that gives the second, to the position that gives the fifth maximum. Okay, so let's assume this is the distance of 2 meters between the first maximum and the fifth maximum. Okay, what is the wavelength of sound wave? Whoa. Okay, so since we have stationary waves, then there must be interference of the two waves. Okay, so a node interfering with being in the same position with an antinode. So let me just draw the shape of the sound wave that has 5 maxima. So I'll produce something like this. 1, 2, no, I need 5 maxima. Okay, 5 maximum is fine. I'll produce something like this. 1, 1, 2, 3. So this can represent the wave coming from the first one, okay, the first speaker. And let me draw the waves coming from the second speaker. The second speaker would give me something like this. You know, you want to have a node to an antinode. So I can have something like this for the second speaker. 1, 2, 3. So this is a node, this is a node. And let me consider the other one. The first signal I have, this is a node, this is a node, this is a node. So these are the 5 maxima, okay, produced as a result of the interference between the two waves, okay. Yes, so you can see that if the distance between the first maximum, let me use color black, color green for this. If the distance between the first maximum and the last maximum, if the distance is 2 meters, let me indicate that here. If the distance here is 2 meters, what does that tell you? Now, from this node to this node, that is one wavelength, okay? From this node to this node is one wavelength. From this second node in the middle to this one at the extreme end, that is another wavelength. So you can see we have 2 waves. This is one wavelength, this is one wavelength. We have 2 waves between all these 5 nodes. You know, you were told that 5 maximum were set up. So I'm focusing on the 5 maximum, and the distance between those 5 maxima is 2 meters. How do I get wavelength? One node to the other node is one wavelength. This node to the other node is one wavelength. So I have 2 wavelengths, 2 lambda. So 2 lambda, 2 wavelengths covers a distance of 2 meters. How do I get the wavelength? Just divide both sides by 2, that's all. That means the wavelength will be 1 meter. That's all. Excellent. So I have my wavelength as 1 meter. That means the correct answer to question number 29 is D. Okay, yeah. So that's it. I've solved the question before, and I put it here. Yes. So these are the 5 maxima. Okay. So if you consider the sound coming from this one, use the color green to represent it. These are the 3 maxima from this. Consider the sound coming from here with color blue, 2 maxima from this, that's total of 5 maxima, okay? So if the distance between one maxima and the other is 1 wavelength, the same thing here, another wavelength, then 2 wavelengths covers 2 meters, hence 1 wavelength is 1 meter. So let's continue with question number 30. Two wave sources emit coherent waves. Which condition must be correct for the coherent waves? When you say two waves are coherent, what does it mean? Constant phase difference. Option A, the waves are emitted in phase. Yes, they might be emitted in phase fine, but the phase difference might be changing, and we don't want that. The waves are emitted, the waves are emitted and move in opposite direction. That doesn't matter. The waves are emitted with a constant phase difference. That is what it means for two waves to be coherent. We pick C, constant wave difference. Question number 31. A student sets up an experiment to investigate double slit interference. The student uses light of a single wavelength from a laser to illuminate a double slit so that a pattern of interference fringes is observed. So this is the laser, the wave passes through these two slits and forms fringes on the screen. The student finds that the fringes are very close together. What could the student decrease in order to increase the separation of the fringes on the screen? So I'll put a diagram here. Now, looking at this diagram, you can see that the double slit, rays of light coming from the laser passes through the double slit, and it goes this way. So if you consider the first one up here, let me zoom in. So rays of light coming from this, it forms a fringe here, okay, and rays of light coming this way form another fringe down here. So there are two. S represent the distance between them, and the formula using the double slit experiment, this is the formula for getting the wavelength, okay. Wavelength is Rs over Q. Now the question has asked you, what could the student decrease in order to increase the separation of the fringes? What is the separation of the fringes? S represents the separation of the fringes. You know, the wavelength is constant. Q is the distance between the screen and the fringe. So let's see. So what are the factors that can, since wavelength is constant, what could the student decrease in order to increase the separation, in order to increase S? Let's make S the subject here now. You see, that means S is equal to what? Take this one here and bring this one down here. So that will be lambda Q over R. So in order to increase the separation of the fringes, since wavelength is constant, you either increase the distance between the double slit and the screen, which is Q, increase Q, or you decrease R, decrease the distance between the two slits, okay? When you decrease the distance between the two slits, then S can increase. So either decrease this, increase this. This one is a constant. So what can you decrease? That's the denominator. Decrease the distance between the slits, okay? That's the separation R of the slit. That's all. So from the formula, you can always get the question to that. No, I'm not doing this. I will do it here. Okay, so question number 32. What are the definitions of potential difference and electromotive force in terms of energy transfer and charge? Potential difference is the work done per unit charge. Also, electromotive force is potential difference is electromotive force. Potential difference is voltage, fine. Also, electromotive force is also the work done per unit charge. Okay, that's why both of them are measured in volts. So A is the correct answer to question 32. Question 33. The diagram shows a network consisting of three resistors. What is the combined resistance of the network between terminal X and Y? These two are in series. So the first thing I'll do is resolve this parallel arrangement, get the total resistance, then you deal with these two in series, add them together. Let's deal with this parallel arrangement. The total resistance of the parallel arrangement will be R1, R2 over the sum, R1 plus R2. R1 is 1.2 multiplied by R2 is 4.7. Then we divide by the sum. R1 plus R2. That will be 1.2 plus 4.7. So 1.2 plus 4.7, that will give you 5.9. 1.2 times 4.7, I'll use my calculator for that. So I got 5.64, okay, as the product. So if I divide these two, I'll get 0.95, okay, or 0.96. Now we will deal with the series arrangement of the 0.96 ohms. Okay, so this parallel arrangement gave us 0.96 ohms. So you add this to this 2.2, okay. So now we have now the total resistance is 2.2 plus 0.96. That should give you 3.16 ohms, which is approximately 3.2 kilo ohms, rather, kilo. 3.2 kilo ohms. That makes option C the correct answer to question number 33. We go straight to question number 34. A resistor dissipates 25 watts of power when there is a potential difference of 4 volts across it. What is the resistance of the resistor? You know, power equals to IV, and that is also I squared R, okay? Also, that same power is equal to V squared over R. Those are the three expressions you can use to calculate power. So I'll be using P equals to V squared over R. What's the voltage? Voltage is 4. Power is 25 watts. 25 equals to 4 squared over R. So that simply means 25 equals to 16 over R. How do I get resistance? R equals to 16 over 25. Is that what I should do? Power equals to V squared over R, okay? Yes, voltage is 4, 4 squared is 16, resistance is unknown. That means R will be equal to 16 over 25. Is that what I should do here? So I got 0.64 ohms. Okay, 16 over 25 is 0.64 ohms, which is B. Question number 35. The diagram shows a cell with internal resistance connected in parallel with a fixed resistor and a variable resistor. This is the fixed resistor, this is the variable resistor, internal resistance. The resistance of the variable resistor is decreased. So we decrease the resistance of the variable resistor. What happens to the potential difference V across the variable resistor? The resistance of the resistance of variable resistor is decreased. Okay, then since V equals to IR, if you are decreasing resistance, then it simply means you are decreasing voltage because voltage is proportional to resistance. So what happens to the potential difference V across variable resistor and the current I in the variable resistor? Also, since I equals to V over R, if you are decreasing resistance, current increases. Okay, so current increases. So when you decrease resistance, current will increase. So the voltage decreases and current will increase. That is, voltage decreases, current increases. That's option B. That makes B the correct answer to question number 35. Question number 36. A radioactive source produces a beam of alpha particles in a vacuum. The average current caused by alpha particles is 1.5 times 10 to the power minus 19 amperes. The beam is incident on a metal target. What is the average number of alpha particles hitting the metal target in time of 3 seconds? We have the time, we have the current. Q equals to IT. Quantity of charge equals to current times time. So how do we get the quantity of charge here? The quantity of charge is equals to current 1.5 times 10 to the power minus 9 amperes times 10 to the power minus 9 multiplied by the time is 3 seconds. So this will give you 4.5 times 10 to the power minus 9 coulombs. Now, they are alpha particle. You know, alpha particle is a helium nuclei with a charge of +2. What does that mean to you? That simply means the charge of helium nuclei, of helium, the charge of an alpha particle, I won't call it, the charge of alpha particle will be what? Two times, okay? Two times of charge of an electron. What is charge of an electron? 1.9 times 10 is, no, I think it's 1.6, right? Times 10 is power minus 19 coulombs. Let me just confirm that here. The charge of an electron, the charge of an electron is let me see what we have here. Yes, 1.6 times 10 to the power minus 19 coulomb. 1.60 times 10 to the power minus 19 coulomb. So that's what I'm using here. 1.6 times 10 to the power minus 19. So I have that. So charge of alpha particle will be twice the charge of an electron. 1.6 times 2, that will be 3.2 times 10 to the power minus 19 coulomb. So if this is the charge of an alpha particle and this is the total charge I'm expecting, then what is the number of alpha particle? Number of alpha particle is the total charge divided by charge of an alpha particle. Okay, so I have 4.5 times 10 to the power minus 9 divided by 3.2 times 10 to the power minus 19. That will give us times 10 to the power 10. 4.5 divided by 3.2. I'll use my calculator for that. So we got 1.4 times 10 to the power 10 particles, alpha particles, which is option C. That makes it the correct answer to question number 36. Question number 37. The charge carriers in a metal wire are free electrons. Which statement about the charge of each free electron is correct? The magnitude of the charge increases with potential difference. Of course not. The magnitude of the charge is zero unless there's a potential difference. No, there will always be charges. Okay, that's metallic bonding. See, the sign due to metallic bonding. See, the sign and the magnitude of the charge do not depend on the potential difference across the wire. The charge will always be negative. Electrons are negatively charged. And the charges will always be there because metals have metallic bonding. That's one thing about crystal lattice. The sign of the charge depends on potential difference. Of course not. The charge will always be there. So that's C. Question number 38. Which flavor of quark have a charge of +2/3? You know, what flavors of quark have a charge of +2/3? The up quark, the charm quark, and the top quark have a charge of +2/3. Okay, take note that a quark can have either +3/3 charge or -1/3 charge, while an antiquark can have a charge of +1/3 or -2/3. Okay, that's for antiquark. Okay, we leave this aside. Quarks that have a charge of -1/3, we have the down quark, we have the strange quark, and we have the bottom quark. So our emphasis is on quarks that have a charge of +2/3. That is up, charm, and top. Do you have up, charm, and top? Top, charm, and up. Okay, so just charm and charm, top, and up. So just charm and top. That's all. Where do you have charm and top? A. That makes A the correct answer to question 38. We have charm and top. A. We go straight to question 39. An unstable nucleus of an element decays by emitting alpha or beta particles. To become a nucleus of a different element. The nucleus is also unstable and emits an alpha particle. Okay, this nucleus is also unstable and emits an alpha particle or a beta particle. The process continues until an isotope of the original element is produced. What is the minimum possible number of these particles? That means the number of alpha and beta particles, the minimum number that can be emitted. Okay, so let's have an example, let's have an illustration Okay, so for an illustration, we deal with an isotope of calcium. Let's use calcium for an example. So let's take, for instance, this isotope of calcium. Atomic number of calcium is 40. Let's just start with a higher value of 44 for mass number, which is 20 protons and 24 newtons. Fine. Now, when it emits a beta particle, okay, so a nucleus of the elements can decay by emitting an alpha particle or a beta particle. Let's start with the beta particle. When it emits a beta particle, beta minus 1, 0, what will be left? 20 will form minus 1 plus what? What will I add minus 1 to get 20? It will be 21. Okay, and let's just name that element X. And what about this 40? 0 plus, okay, this will be 44. Why? Because 44 plus 0 gives me 44. So now this is what is formed when calcium emits a beta particle. Now let's talk about the alpha particle emission. When the element that is formed emits an alpha particle, let me write this properly. So I want to talk about the emission of alpha particle now. When this element X that is formed, 44 and 21, when it emits an alpha particle, 42, what will be produced? Let's go. 44 minus 4, I have 40 here, and then 21 minus 2, I have 19 here. So an element Y is produced. Now, this can continue in either way, but we just want it to continue until calcium is formed again. So should we allow it to undergo an alpha decay? When it undergoes another alpha decay, this number reduces further to 17, okay? Because alpha particle has 2 protons. So let it undergo a beta decay. When this Y that is formed, Y 40, 19, when it undergoes a beta decay, beta minus 1, 0, what will be formed? 19 minus 1, that will be 20. Okay, now we have our calcium back. 40 minus 0, that will be 40. We have our calcium. So the minimum stages it can go through 3 stages, okay? A beta decay, alpha decay, and beta decay. Minimum we can have is 3. Now you go to question number 21. Question number 40 rather, the last question. A nucleus of carbon-10 decays by beta emission to form a nucleus of boron. For this decay process, what is the change to a nucleon, and what is the change in the quark composition of the nucleon? Okay, let's go. So since carbon 10, 6 will form boron 10, 5, plus there must be a beta particle, beta 10 minus 10, 0, 6 minus 5, 1, plus 1. What does that tell you? This is a positron. This is a positron. And what kind of radioactive decay would lead to the production of a positron? For a positron to be produced, that means one proton would change to a neutron. One proton, 1, 1, would become a neutron, 1, 0, plus then there will be the emission of a positron. Okay, so what that simply means is that for carbon 10 to become boron 10 with the emission of a positron, that simply means one of the protons in carbon has been converted to a neutron, and in the process a beta particle was produced. What is the composition of a proton? Now, what change happened to the nucleon? That means a proton has changed to a neutron. That is what has happened. Okay, a proton has changed to a neutron. Now, what is the composition? What is the makeup of a proton? A proton is a down, up, up quark. That is what makes up a proton. While a neutron is made up of a down, down, up quark. Don't forget that proton is positively charged, okay, while a neutron is it has a neutral charge. Yes, it has a neutral charge. So if you have down, down, up, up is plus 2 over 3, down is minus 1 over 3, minus 1 over 3, minus 1 over 3 plus 2 over 3, that will give you 0. Okay, that's a neutron, neutral. While a proton is positively charged, down, up, up, a proton has a charge of plus 1. So if I do down, up, up, down is minus 1 over 3, okay, then up plus 2 over 3 plus 2 over 3. If I do 2 over 3 plus 2 over 3 minus 1 over 3, I will get 1, okay, that's a proton having a charge of plus 1. So doing the beta plus decay, okay, during the emission of a positron, a proton becomes a neutron and a positron will be emitted. So it's like down, 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 up, up is being converted to down, down, up. In essence, what we are simply saying is that an up quark, okay, rather, will be converted to a down quark. Okay, yes, down, up, down, up. So an up quark will just be converted to a down quark. That is what happened during a beta plus decay or during the emission of a positron. So a positron will be emitted in the process. So an up quark becomes a down quark. Up becomes down quark. Okay, that's correct. That makes B the correct answer to question number 40. This brings us to the end of this paper. Ensure you subscribe to this YouTube channel so that you can always get more of this. Thank you for joining me today. You have a nice day. Goodbye.